Okay, question number 20 here, and the first thing to note is that we have another one of these asterisk questions, so it's another quality of written communication question. So that means the examiner wants to see really clearly what we've done and how we've done it. The question's about vectors, and it's actually asking us to show that line AMD, so if we draw that in now, line A to M, and then M to D, to show that that line there is a straight line. What this is actually asking us to do is show that this portion here, A to M, and this portion here, M to D, have the same gradient, because lines that have the same gradient are going to be straight. So let's have a look at the other information in the question and see what we can fill in. Well, the first thing we can see is that B is the midpoint of AC. So we have AC here, B's in the middle, so what we can tell when we're talking about vectors having direction and magnitude is that if this part of the diagram here is represented by the vector of A, then I know that this part of the diagram here is also going to be represented by the vector of A. We have some other information here in terms of a vector here being B and a vector here being 2B, and then we need to get on and find some of these vectors. So the first one I'm going to look to find is BE, because I know at some point later on in the question I'm going to be trying to use the point M here, so I'm going to need to be able to navigate to it. So let's look for then the vector from B to E. Now I want to travel from point B here to point E here, but I currently can't travel along here because there's no vector notation to give me this pathway. I can, however, travel this way, and to travel along there I'm going against vector A, so that's going to be represented as negative A, and then I'm going to travel along here, and as I go I'm going to go against this 2B, so that becomes negative 2B, and I'm going to go against this B, so that's going to be negative B. So if we summarise all that information and simplify it, I've got minus A, minus 2B minus another B is minus 3B. So I've now got the vector B to E travelling in this direction as minus A minus 3B. Okay, what I can now do is I can now find M to D. So I'm going to look for some vector notation that takes me from point M to point D. And that's going to be given using the journey here, so this portion here, and the journey here. So what we know is we've just found previously that this whole length here from B to E is minus A minus 3B, and as M is the midpoint of this line, I want to travel along half of that vector. So I'm going to travel along minus a half of A, and I'm going to travel along minus a half of 3B, so 3 over 2B. So that's that part of the journey there. I then need to incorporate the part of the journey here, and that's going in the right direction with B, so I'm going to add B. So if we now tidy this up, I've got minus half A, and I've got minus 3 over 2, so minus 1.5 B's plus a B. That leaves me minus a half B. Now what's really important here is that we tidy this up by pulling out what's known as the scalar, or in any other example the factor, and so we're left with the gradient. So there's minus a half here and there's minus a half here, so that can come outside, and that's going to leave me with A plus B. So we have our scalar and we have our gradient for the part MD. What we're now going to move on to is try and find some kind of vector notation here for the travelling of points A to M. So let's look at how we can get from A to M, and if we've done it correctly we're going to find that it's got an equivalent gradient to M to D, so we can prove that the overall line must be straight. So to get from here I'm going to travel along here, which means I'm going against this A here, so I'm going to have negative A. I'm then going to travel along this portion here, which is the other half of the vector BE. So I'm going to have minus a half of A, and I'm going to have minus a half of 3B. So let's tidy this one up. And we've got minus a whole A minus half of an A. Well, that's minus 1.5 A's. I'm going to change this 3 over 2 to 1.5 because that's equivalent. And again, I'm then going to tidy this up like I did for the vector m to d, and I'm going to pull out the scalar. So I'm going to pull out what we talk about in terms of a factor. So both of them have minus 1.5 in them, and if I pull that out, I'm left with the A and the B, and what we then have as a conclusion is we would say that as vector for MD has a gradient of A plus B, and AM has a gradient of A plus B. Therefore, equal gradients mean the line must be straight.